Okay, so we are starting with part 2 of the queues part. Now here we will be taking up competitive programming questions from lead code and the most asked questions on queues and different places where they can be used and how they can be used, and how we can use queues in order to implement other data structures, and so we'll have all that. Look, okay, now here, so we'll get started with queues implementation. So yahan pe you will be understanding the class functionalities also, how we declare a class and how we define different methods within it. So consider queues as a class. So we are going to create a queue class, and then we are going to define different methods. These methods will be the similar kind of methods which we have been using earlier. तो ये जो queue operations आपने अभी use किए थे, ऐसे ही similar methods हम अपने queues में बनाएंगे, ठीक है? क्योंकि हमारा जो ऑब्जेक्टिव है वो है कि वी हैव टू इम्प्लीमेंट द क्यू यूजिंग अ लिस्ट. ओके, दिस इज द फर्स्ट क्वेश्चन कंसिडर. So there could be different kind of questions. You can implement a queue using a stack. You can implement a queue using an array, things like that. Okay. So if somebody asks you implement a queue using an array in Python, so we don't have arrays in Python, we have list. So you can use this implementation of list in order to implement queues. Now, so we'll go step by step, and I'll quickly walk you through what are we going to implement in it. So there will be multiple methods which we will define here, but the very first one I have defined here is a queue class where we have defined an initialized method. We are initializing a queue data structure. Now, what are we doing here? We are defining the size of the queue. Let's say what should be the size of the queue. This is something we are bounding our queue. Okay. So suppose I say I'm going to create a queue with the size of 10. That means I can have only 10 nodes. So in this, the max length of this queue will become 10, and we cannot have more number of elements in it because we have defined the size. Now, how we define it? So the first thing is we have to create a list to store the queue elements. Whatever number of nodes you want to add it onto a queue. Suppose you have a queue at the top here, 6, 23, 4, 7. These are all the nodes, and you want to store these nodes onto a list. Okay. So we are creating a list which is empty at the moment, and it is going to be multiplied with the size of how many number of nodes do we want. So suppose if I say I want to create a list of size 10. So that means I'm going to take 10 and I'm going to make a list, and I'm going to have that number of spaces for my queue structure, and I'm going to call it as queue. Okay, so queue is a variable representing my queue which I'm going to create. Second step in the initialization, what I'll do, I'll define a maximum capacity of the queue. What should be the maximum size of a queue which we can hold here? So since we are creating our custom queue, we can quickly maintain the size of that. So whatever size we have given, we are going to save that size as the capacity of the queue. Okay. Similarly, what next we are going to do? Then we are going to have a pointer kind of concept where we will be pointing to the front of the queue, and we will be pointing to the back of the queue. So in order to point to the front of the queue, you're going to point to index number 0. And if you want to point to the nth node of the queue, which means the last node, you're going to point it using -1, because you don't know what is the size of the list. Okay. So we are going to point it to the -1 index. So that is going to be the last element. Similarly, what you're going to do, then you're going to identify the current size of the queue, that what is the current size of the queue. So we have 0 initially. Once we start the queue, once we initialize the queue, it's going to be completely 0. So let us quickly implement the stuff. On the left hand side, I'm going to quickly start a class. So you can use this class keyword, and suppose we are trying to implement a queue, and this queue is our custom queue. Okay. So class hum banate hain is format pe. Now what you're going to do, you're going to define an init method. So let's say I'm going to define an init method. The first will be a pointer to the self, so that we can access this queue. This is the default implementation of the constructor or an initializer in a class in Python, so that you can quickly reference to the object whatever you have made. So self is an object with which we will be able to perform all that operations. Okay. Now we're going to get access to the self. The second property which we do need to define is the size of the queue. What should be the size of the queue? So we have initialized it. Now there are a few steps which we want to implement. First, what should be how many number of elements we should be able to store into that queue. So again, we're going to make a list. Let's say I have taken an empty list, and I'm going to multiply that with size. Okay. So this is going to be my size, and I'm going to access my element using self.queue. So I have created a random variable queue here, and this random variable queue will be accessed using my object self. And what I'm doing is, on this memory, I'm allocating a list of size n, whatever size I'm going to define when we are going to create the queue. Okay. Now, what should be the maximum capacity of the queue? So we are going to define a new attribute, self.capacity. Okay. Let's say the capacity of the queue should be the size of the queue, whatever I have defined. Okay. Similarly, we need to point to the front of the queue, which means, let's say if I open this, so you really want to point to this element first. Let's say this is your specific queue. Okay. So what we have done, we have defined the size. Let's say the size is going to be some 10 number here. Then we are using a list implementation. अगर आप कोई और data structure use करना चाहते हो तो दूसरा data structure भी आप use कर सकते थे. But since we are implementing that with a list, so I've used a list here over this none. Now I'm pointing to the front of this queue. Okay. So I'll say self.front. I created a variable self.front. It could be anything. It could be front, it could be top, it could be head. You can use any keyword as per your choice. Okay. So I'm going to say the front will be pointing to index number 0. And then I want to point to the last element. So pointing to the last element will be something like, let's say we are taking here rear. Okay. You can take it as self.last also, or self.rear, anything, any word which you want to use. So that's how we initialized it. And now the finals, we want to give it the size of the list. So size attribute will also be there. So I'll say the size of the list by default will be 0. Okay. So are you guys clear with the first method? We are done with the initializer of queue. So now once my queue will be initialized, it will have the following properties. It is going to be a list of size n. The maximum capacity will be the size, whatever size we will provide to this constructor when we are going to initialize, or when we are going to create a new instance of queue. Okay, that we are going to do at the bottom. Currently we are initializing this class and we are initializing all the attributes. Now the next attribute we have is the capacity. We have the front, we are pointing to the front, we are pointing to the rear, and we are pointing to the size of the list, whatever is the size. So currently it is 0. Going to the second step. In the second step, what are we going to do? We are going to write a function to dequeue from the front element. Okay. तो अभी आप लोगों ने पीछे देखा था कि हम एक pop functionality implement कर रहे थे. ठीक है. This was the functionality which you were implementing. Let's say you were popping the element out. So if I clear it here and if I show you, if I want to dequeue, if I want to dequeue is the same implementation of pop. So what will be done? Let's say I'm going to pop it from the back. Okay. So here the pop left has been executed, but we want to pop it from the back. Suppose the last element has to be filtered out. So how we are going to implement it? Let's have a quick look. So we are going to write a new function which is going to pop from this list now. Okay. So we are defining a function pop and we are giving it the same object of us, which means जो मैंने queue बनाया, अब queue का जो भी initializer object हम instance create करेंगे, we are passing that instance to the pop कि ये pop operation किसके ऊपर उसे object किसके ऊपर apply करना है. ठीक है. Now, so there are a few steps which we want to perform. First is we need to check the queue underflow, which means ऐसा तो नहीं है कि हमारी queue खाली है, जो भी हमारा queue है that is empty. Okay. So you can quickly check back using your object. If it's not empty, or if it's empty, we are not going to perform any of the process. We'll say that queue is underflow. Okay. Print terminate. Let's say I'm going to terminate the process and I'm going to give a error kind of value that the queue object is not available and we cannot add anything into that. Okay. So now, so if the initialization is done properly and if we do have that self object, then isEmpty will never be empty. Okay. And we will be able to add up values here on the pop functionality. Now, so what are we trying to do? Now we are going to implement the method. In case if we do have the right object, now we are going to implement it. So let's say I want to remove an element which is available at the front. Okay. So what I'll try to do. So here what I'm doing is we have printed a specific statement here, removing element Okay, so removing element as in it will give you a quick message at the bottom that which element is going to be removed. So from our queue, self.queue, we are going to access the front element, self.front, because we want to remove this element. So self.front, you already know the element pointing at index number 0, and self.queue is your list from where you want to access the index of that element. So self.queue is the queue, and from that queue within the index we are trying to access the front, which is 0. Okay, so we'll get to see that. Okay, we are going to get a message removing the first element, let's say pop left from the list, जैसा भी यहाँ पे हो रहा था कि हम first से remove कर रहे थे. अगर मान लो आप end से remove करना चाहते हो, you want to remove it from the end, तो फिर आप यहाँ पे rear डाल दोगे. ठीक है, you can simply use it rear, that we are removing from the rear. But let's implement the same functionality. We'll pop from the will dequeue as in the first element will be removed out. Okay, now what are you trying to do? Then you will identify the front element. So you have that index, you're going to get the next element, and you will see the reminder with respect to the capacity, how many are still available, and we will get the front element. Okay, so let's change the head to front. So what is going to be the next index? So we have taken the front, we're going to add one to it so as to point out to the next element, and we'll take a mod. Okay, self.capacity. The mathematics of this, I'll share some resources with you so that you can understand how these mathematical operations are done, and I hope you all have studied it as well. Now, so how many number of items will be left now? So earlier the count was 0, but now after the initialization, we might have some n number of items in the list because we are implementing the queue using the list. So we are going to get that count, whatever is the count, and we are going to reduce it by 1. Okay. So that is somewhat is the pop operation which we have performed. So here is the pop operation which has been done. So we are removing the first element, and then we have performed this mathematical computation. We have taken the index, we have added one, we have modded with the capacity with the size, and then we have put that value onto the front, which is going to be the value. Okay. Now, so we got this self count. Next चलते हैं. Next function आप define करोगे adding elements onto the queue. Okay, let's say define add elements to the queue. So what do we want to add? Let's say we want to add some item. Okay, item or a value. Say हमने यहाँ पे value use किया हुआ है in the reference. So I'll make use of the value itself so that it will be relevant for all of you. So अब अगर हमें element add करना है, तो मान लो मेरे पास एक n number of items हैं. मान लो सबसे पहले हम चेक करते हैं overflow तो नहीं है, because we have a bounded property set here. हमने वहाँ पे capacity define किया हुआ है. तो अगर मान लो 10 elements हैं and already queue filled है with the 10 elements, so we cannot put 11th one, otherwise overflow हो जाएगा. So first thing what we do is we do check it. ठीक है, तो pop तो था ही, यहाँ पे add की जगह we'll call this method as append so that it makes more sense, because in general ऊपर जो आप लोगों ने देखा था वो append ही method implemented है. Okay, so append was the element which we were giving certain value, and the same type of method we are defining here. So self is the object to the queue and the value which we want to add in. So that is going to be the argument we'll take, and we'll append that value here. Okay. So we are adding an element to the queue. Now what you want to do? So let's first check the overflow. So we are going to check if self dot is full. Okay. In case if we already have the size overfilled, so we'll say overflow condition. Okay. And we are going to give an error-based exit. Exit 1 means we are exiting, we are terminating the program, but we are giving it an error code that there is some error in the process, and we are sending this information to the kernel. So it gets to know that, okay, you might have some trouble, like in case if you're appending to a queue which is already filled, we cannot do that operation. Similarly, in the above, when we were popping it out, in case if we don't have any element, we already have the queue empty, we cannot pop any element out of it. Okay, so these are the conditions which we generally check. Now what we'll do? So we'll quickly give a print statement. Let's say we'll say inserting a value. So whatever value we are going to get from the user, we'll print a statement that yes, we are inserting the value into it. And now since we have to append it, so we will change the rear tail. Okay, so changing the rear tail means you're going to get the index of the rear, add 1 to it, and take a mod operation with the capacity, and you'll get the new rear. Okay, so self dot rear, we are getting a new rear here because once the item is going to be appended, we are going to get the new rear. So self dot rear plus 1, and make a mod, make a percentage with self dot capacity. Self dot capacity. Okay, so that's how we got the new rear with us, and now we are going to assign the value to that rear. So we'll call self dot queue. This is our queue. On this queue, I'm going to enter at this index. So self dot rear is the index where I want to put a value, and then I'm going to assign a value. So here you can see, first we calculated the new rear where we do have to append. We got that index, and on that index on the queue, we have added that value. Okay. Now, once we added that, the count is going to increase. So we are going to increment the count by 1, self dot count plus 1. Okay. So we are done with the append operation also. So you can see we have defined a class queue, and we have got 3 methods defined within this: init, pop, and append. Now we'll go to the next part. Okay. Within this next one, what you are going to do, you're going to write a function to return the front element of the queue. Okay. So this is the peek operation. So peek, you have seen, once you perform the peek, you will get the topmost element out of the list. So how does it actually done? So it returns head of the data. Whatever you have on the top, we are going to return it back. So this is a big of one operation because it's just one accessing returning statement. Okay. So let's just define the peek. So we're going to define this method, define peek. We're going to give the self object. Now within this self object, what we're going to do, again, let's check if self dot is empty. Okay. So we are going to say my queue is empty, queue empty, and we're going to terminate the process. We're going to terminate it. Otherwise, we're going to simply return from the queue, self dot queue, we're going to return the front element, self dot front. Okay. So you can see that we have got access to the queue, and we are simply returning the element at an index, self dot front. So whatever is the value, it will be returned back when you call peek. Okay. Now going to the next step, we are going to define a few more functions like the size which we wanted to check. So let's define the size of this data structure. So we took an object self, we took return self dot count. Whatever is the size of your queue is, we do have that value available in the count, because once we are removing, we are decrementing the value. Once we are adding new elements, we are incrementing the value. So finally, count is going to be changed. And initially, we have defined the count specifically. We have taken that specific count value. यहाँ पे हमारे पास साइज था, ठीक है. सो यहाँ पे हमने सेल्फ लिया, सेल्फ डॉट काउंट हम यहाँ पे रिटर्न कर देंगे, ठीक है. आई थिंक हमने फर्स्ट में काउंट हमने डिफाइन किया था ना, करंट साइज. Yeah, so I took it as size. Okay, ठीक है. So और तो कहीं मैंने साइज यूज नहीं किया ना, हर जगह हमने काउंट ही यूज किया, ठीक है. So size is the method, and we have actually defined the specific count value. So now you can see we have returned the size of the queue also. Finally, what next we're going to do? You're going to write the function to check if the queue is empty or not. ये जो आप ऊपर use कर रहे हो is empty and is full. We are going to write a function for that also. Okay. So we have defined is empty. How you can quickly check if your queue is empty? You can quickly return if self dot size. Okay, we have already defined the size method above, is equal to 0. If the size is 0, that means it is empty. Your queue data structure is empty. Going to the next step, we are going to check the functionality if it is full or not. Okay, so define is full. Okay, so we are going to take the self object, and we are going to return the size of the element if it is equal to self.capacity, which we have defined above. Okay. So now we are done with all the specific methods. We initialized the queue data structure. We have written a pop operation. We have written an append operation. We have written a peek operation. We have written a size. We have written is empty. We have written is full. And now we are done with this particular step. So now you can quickly test your data structure. Okay. So we can quickly run it for the time being. So we are done with the initialization of the queue. And I have got some messages. Let me just quickly check back. I am having network issues. We'll listen to the recording. Okay. Now let's see. So here, I believe you guys are clear. Okay. Now let's go for the final part. You can test the queue data structure now. Okay. So we can perform all these operations, like we can initialize a queue, we can append the queues, we can print the size, we can check what is at the peak, you can pop an element out, you can check if the queue is empty. All these things we can quickly check it. So let's just get started with if name is equal to, let's say, main, and we're going to define something. Okay. So I'll say I'm defining my custom queue. Let's say this is going to be our custom queue. Okay. And we are going to initialize that with queue. And I'll say there's a size of 10. Okay. So once I run it, I'm going to print, let's say, size of the queue is, let's say, custom queue dot size. Okay. So you can see that since we don't have any elements appended as of now, so currently it is 0. Okay. Now what am I going to do? Let's quickly add in some element. Custom queue dot append. Define an append method. I'll append 10. Okay. I'll append a few elements. Let's say I've appended 10, 20, 30, and 40. Okay. Then again, I'm going to quickly get back the size. Okay, so I have inserted 10, 20, 30, and 40. And now you can see I have got the size of the queue updated to 4 specifically. Now what am I going to do? Let's just quickly take a custom queue and pop it out. Okay, once we pop it out, let's just pop it out. So we have removing the element 10, which is from the pop left. The first element has been removed out, and we got that the element has been removed. Okay. Now, what next we're going to do? We do know the size. Now we'll check if the queue is empty or not. So let's say if your custom queue is empty something. Okay. So I'm going to get print empty queue, else will print non-empty queue. Okay. So let's just print it. So we are going to get that response. It's a non-empty queue. Okay. So guys, I believe you're clear with this particular stuff, that how we can quickly create a class here. We can define our initial method and the attributes. We can define n number of attributes with respect to whatever kind of data structure we are planning to build. Then you can define all your methods, popping the operation, append operation onto the queue, peek operation, how to get the size, how to get if that list is empty, how to check if it is full, and then your main sequence code. Okay. So you can implement n number of methods, and as you already know, Python is completely open source. So you can go to that source and you can see how they have implemented the code, which we have already discussed a lot in the previous sessions, that the source codes are available and you guys can actually have a look. Okay. So is Jaideep is not in the meeting?
No, sir, I guess he is not.
Achha, I'm having network. We'll listen to the recording, might drop. Okay, maybe. चलो, anyways, ठीक है. आरुष समझ में आ गया ये?
Yes, sir.
Clear है?
Yes, sir.
Okay, nice. So we have implemented the queue properly. Queue implementation हो गया हमारा. Now we'll go to problem number 2. Okay. So now let's say we do have more number of problems. So how can we generate binary numbers between 1 to n using queues, let's say, something like that we have to implement. So we have implemented these problems here. So you can quickly see here over these interview questions. Let's have a quick look. We will create the collection for a generate method, create a queue, print the element, then loop to all the elements, top left and label on the front item, then the new element, that and that, and all that. So with this approach, you can actually quickly get to have how to identify the binary numbers between 1 to n using queues. Okay, and here we do have an implementation here. So on your support panel, we have shared, and you have the complete implementation of the code here, that we can create an empty queue, and you can run the loop for n number of times. We can remove the front element, we can append 0 and 1 to the front and enqueue both the strings, and finally we can print the front element out. Okay, so that's how we can actually generate binary numbers using queue between 1 to n. Okay, similarly, there are a few more challenges which the participants have to implement. So the next challenge is something like calculate the height of a binary tree using queues. So how that can be done? So you have to calculate the height and you have to write a specific function for that. Okay. You can create a class, initialize your key left and right, so creating binary tree here. So हमने रूट डिफाइन कर दिया binary tree का, height select कर ली, कौन सा एलिमेंट मैक्स है उसको अकॉर्डिंगली सेव करेंगे. First is only this element, left side of the binary tree, right side of the binary tree, and finally we will calculate the height of it. Okay, so in a simple fashion, we do have this particular stuff कि आपको initialize करना है अपना method, और specifically left right pointers attributes आपने create कर लिए, what will be pointing to left, what will be pointing to right, and then you can insert those values out, and you can get that solution done. Okay, going to next problem. There is one more problem available over here. Implement stack using queues in Python. Okay, we have to implement stack using queues in Python. So let's just open that also. Again, एक stack बनाए class, दो dequeue बनाए, add operation आपको बनाया So somewhat like that. These are approaches with which you can quickly take up the problem and solve these problems out. Okay. The next one is efficiently print all the nodes between two given levels in the binary tree. Okay. So for that, what we have is ये फिफ्थ प्रॉब्लम स्टेटमेंट है कि आपके पास जितने भी नोड्स हैं, एक बाइनरी ट्री बनानी है, उसमें 2 लेवल्स आपको देने हैं, उन 2 लेवल्स के बीच में जो भी नोड्स आते हैं वो हमें एक्सट्रैक्ट करने हैं. ठीक है. So उसका solution approach is available over here. Again, I'll just quickly open that also. So हमने collections ले लिया, dequeue import किया, हमने एक node class बनाई, क्योंकि हमें करना क्या है, हमें सारे nodes print करने हैं 2 levels के बीच में जो binary tree के अंदर हैं, and we have to make use of queue implementation. तो हमने एक node class बनाई, binary tree के हमने left side of the binary tree, right side of the binary tree बना लिया, हमने key बना लिया, key element, फिर हमने left बना लिया और right बना लिया. One will be the key and 2 different will be the left and right of the node. Okay. अब हम एक function बना रहे हैं print nodes. इस print nodes function के अंदर हम क्या करेंगे? We'll have the root of the binary tree, will have the start level and the end level. Okay, इन दोनों levels के बीच में से हमें items को print करना है. So we checked if the root is none. हमने एक empty queue बनाया, elements root level 0 initialize किया, define किया. अभी जब तक क्यू के अंदर एलिमेंट होगा, ठीक है, तो हम अपने लेवल को 1 by 1 इंक्रीमेंट करते जाएंगे एंड हम क्यू का साइज चेक करते जाएंगे और उसको साइज में पेस्ट करते जाएंगे, ठीक है, बिकॉज वी हैव टू आइटरेट ओवर द क्यू. We are processing every node and we are enqueuing non empty left and right child जो भी हैं, ठीक है, उनको हम एड अप करते जा रहे हैं, मतलब रिमूव करते जा रहे हैं, पॉप आउट करते जा रहे हैं. सो हमने चेक किया साइज अगर हमारा क्यू का 0 से ज़्यादा है तो हम एक एक करके साइज को कम करते जा रहे हैं, ठीक है, और एलिमेंट्स को पॉप करते जा रहे हैं डिपेंडिंग ऑन किस लेवल पे आ रहे हैं. अब अगर हम उस नोड को प्रिंट करेंगे कि अगर हम अपने करंट लेवल पे आ गए हैं और वो लेवल हमारा गिवन लेवल है स्टार्ट और एंड के बीच का, तो हम उन नोड्स को प्रिंट करते जाएंगे. Here is one of the nice way of implementation of double conditions. So in case अगर आप ऐसा चेक करना चाहते हो कि we do have a level value and if my level is greater than the start and smaller than the lower upper level which is the end level, so we can quickly have this conditional check if start is less than equal to level and level is less than equal to end, and then you can quickly print the keys. Okay, so keys will be the key. अब अगर हमारा जो करंट एलिमेंट है लेफ्ट नोड है तो हम उसको अपनी क्यू में अपेंड करते जाएंगे. राइट एलिमेंट अगर है राइट में अपेंड करते जाएंगे. सारे के सारे एलिमेंट्स हमने अपेंड कर लिए, मतलब जो भी हमारे लेवल के बीच में आ रहे हैं, ठीक है. इफ my level is greater than start and is smaller than the end, और उस बीच में जितने भी नोड्स आते जा रहे हैं with respect to my current key, I am printing all of them and I'm checking if the node is a left node or a right node, तभी मैं उनको queues में append करता जा रहा हूँ. And finally I'm going to print. एक बाइनरी ट्री बना लिया. देयर इज अ सेंट्रल नोड 15, फिर लेफ्ट साइड पे 10 डाल दिया, राइट साइड पे 20 डाल दिया, फिर लेफ्ट के लेफ्ट में 8 डाल दिया, लेफ्ट के राइट में 12 डाल दिया, और फिर राइट के लेफ्ट में 16 डाल दिया, एंड फिर नेक्स्ट 25 डाल दिया, नोड 30 डाल दिया, स्टार्ट लेवल डिफाइन कर दिया कि मेरे को लेवल 2 और 3 के बीच में जितने भी नोड्स हैं वो मुझे प्रिंट करने हैं. फाइनली हमने जो भी हमारा वैल्यू है उससे स्पेसिफिकली वुड स्टार्ट एंड के हिसाब से प्रिंट कर दिया. तो अब अगर आप देखोगे ये हमारे एलिमेंट लिस्ट है 10, 20, 8, 12, 16, 25. This is the binary list which is available with us between the level of 2 to 3. Okay, that we got that printed out. So these are some of the specific problem statements which we have already explored. So I'll quickly give you a quick walkthrough of what all we have covered today. So we started with the basics of first in first out data structure, which is the queue data structure. We understood the front, back, the enqueue and the dequeue operations. Then we implemented one sample using collections. We have gone through all the detailed operations of queues, whatever is available with respect to Python documentation. We have implemented each and every one. Once we're done with that implementation, we have taken one interview question problem wherein we have implemented a queue using a list. And here on the left hand side, you can see that we have that complete code of the queue with all the methods defined, all the operations defined, pop, append, peek, size, empty, full, and we have implemented this custom data structure queue. Once we're done with defining all these steps of queues, we have seen some few problems of interviews, whatever is being asked, generation of the binary numbers between 1 to n using queues. So approach and codes are available, and you guys can have a quick reference. ठीक है, आरुष, is that clear? यहाँ तक?
Yes, sir. Yes.
आरुष, ये काम आपको करना पड़ेगा. Now what you have to do is you have to practice it. Okay. So मैं आपको ये दे रहा हूँ. I'm sharing the link with you, आरुष 1 के नाम से. Just keep this link with you. ओके, इस लिंक को एक बार ओपन करना, ठीक है, और ओपन करने के बाद ये पूरा सीक्वेंस में स्टेप बाय स्टेप इंप्लीमेंट कर लेना प्रॉपर्ली, ठीक है, ऑन योर नोटबुक. और उसके बाद में वो सारे के सारे कोड्स बना करके काइंडली अपलोडेड ऑन योर गिट या फिर अपने ट्रेलो कार्ड के ऊपर अपलोड कर लेना, ठीक है. तो दिस इज द असाइनमेंट दैट ऑल दीज 5 प्रॉब्लम स्टेटमेंट्स हैव टू बी इंप्लीमेंटेड इन सीक्वेंस. एंड इफ यू हैव एनी क्वेश्चंस, पोस्ट इट ऑन the Trello card. Okay. Arush?
Yes.
So is the concepts well understood?
Yes, sir.